Yes, where is Cricky? I made a video for him about 3 or 4 days ago. This one right here. School time. I was going to help him out. He said he didn't understand the difference between a small circle, which is a latitude line on a sphere, on the sphere of Earth. The latitude lines are called small circles, also called parallels, right? He said he didn't understand the difference between that and a great circle, which is the equator is a great circle. Great circle is the largest circle you can draw on a sphere. It bisects the sphere. All longitude lines are great circles, and they all intersect each other. And the latitude lines, the small circles, are a turn on this sphere. The sphere is forcing you to turn if you are anywhere except the equator. The equator is forcing you to go in a straight line. That's the path it's moving. So I put out this video in good faith because I actually felt he was being sincere when he said he doesn't get it.
Now, p-brane likes to say that all great circles are straight lines and latitude lines are turns. Now, some of the literature does sort of say that, but to me, they're all circles, right? Every one of them is a circle. So why is one turning and the other one not? I don't get it. So why is one turning and the other one not? I don't get it. I don't get it.
I didn't just talk or make graphics. I have a physical sphere, and I showed him the difference between the great circle and the small circles and how the small circle is a turn. And in spherical geometry, this is what it says. The geometry of a sphere, known as spherical geometry, focuses on the properties and figures located on the surface of the sphere. That's what you're missing. You're just saying a circle is a circle. You don't see how one is a turn and one you traverse straight. One you traverse in a turn, the other one you traverse straight. You don't see the difference. Okay, here we go. You're gonna get it after this for sure. You better. All right. This is rotating east, this ball, right? Okay, this arm right here, this is a tangent to the rotation or at a right angle. Everything moves at a right angle to that. That's how it starts anyway. Now, this is a straight line called a great circle. I've gone over great circles a lot. It's the largest circle you can draw on a sphere, and you traverse it straight. Here's my little Lego person. They would traverse it like this. Okay, and my little Lego guy represents water. Right, so I have a person because I want you to see the orientation of people on the surface. This is all about the surface of a sphere, which is perpendicular to the center. And we, standing on the sphere, would also be perpendicular to the center of the Earth. This latitude line, here like maybe 70 degrees north latitude, representing the ground, is a turn. Now you have to keep looking at the surface. Try to be perpendicular to the surface so you can see. That's a turn. This one, great circle, is straight.
Now, p-brane likes to say that all great circles are straight lines and latitude lines are turns. Now, some of the literature does sort of say that, but to me, they're all circles, right? Every one of them is a circle. So why is one turning and the other one not? I don't get it. So why is one turning and the other one not? I don't get it. I don't get it.
As per Newton's first law of motion, everything wants to go in a straight line. So this, say it's about 400 mile per hour moving water, rotating, wants to go in a straight line. And as far as being on the surface, there are actually like two frames of reference. You have the non-inertial frame. That means the one that's not still, but actually the one that's moving in your model is the Earth. So from that frame of reference, all you would see is this latitude line represents the ground, and it is separating. Both are moving, let's say 400 miles per hour. The blue represents the water, the blue line. You would see the water moving south as you're standing on the sphere. Now, looking at it from above in the inertial reference frame, which means still non-moving, that would be space, you would see this whole thing moving together, but you would still see, it would almost be like spiraling, but it would be moving together, and you would see the water separating from the land until it hits either the bank of whatever's holding the water, a Great Lake or ocean or a pond, whatever, or it would collide at the equator with all the stuff from the south would do the same thing. Okay, so your cylinder idea is this. So I put this on here. Now this is kind of this is a cylinder. This is what you're saying. Now, remember your lines, or your circles, your circles are slices of a sphere. So it has the surface of the sphere. They're not cylinders, as you tried to make out. This person would have to walk this way around, or actually she has skates on, would go this way, all the way around the sphere. Well, that's not how you traverse a sphere. You're not at this angle. We're not at that angle to the sphere. No, we're at this angle. You have to take the ground. So get that out. We're not that. You traverse it like this. And this is a turn. All the way around, just like if you laid a hula hoop down at the North Pole, clearly you can see this is a turn. Okay, so clearly you can see this is a turn. Right? So, yes, you can look at a latitude line like this and say, oh, it's a straight line. No, it's not a straight line, because you have to take the surface into account. You traverse a different part of that line because it's a slice of a sphere, because it's a slice of a sphere, because it's a slice of a sphere, not just a circle. Well, I'll take it like a hula hoop. Right? Now, if you traverse the hula hoop this way, that's a great circle. You traverse it like this. That's a great circle. That's at the equator. That's the only place the ground would have you traversing in a straight line. As you move up, you start to move onto this side, and you travel like this. And then when you get to the North Pole, now you're traversing in a circle. Right around, you can go all the way around in a circle. See how that works?
Now, p-brane likes to say that all great circles are straight lines and latitude lines are turns. Now, some of the literature does sort of say that, but to me, they're all circles, right? Every one of them is a circle. So why is one turning and the other one not? I don't get it.
So it's been 3-4 days and he said nothing. I'm just wondering, where'd he go? Is he a flat earther now? Is he struggling now with this? And one of the experiments he did at the final experiment in Antarctica was something on rotation, because he was saying he did some experiment with weights, whatever. Well, how can you be doing experiments on anything?
I don't get it.
CriticalThink, Cricky? If you don't know how a sphere works, a rotating sphere.
I don't get it.
You don't know the difference. I think you need to learn some fundamentals first, right? So Anyway, I mean, I thought you were sincere, but now you're not coming back and saying, wow, thank you. I get what you're saying. It doesn't change my mind. I still believe I live on a spinning ball, at the moment anyway, but I appreciate, you're right. Why don't you come back and say that? Then you either have to just continue to deny or maybe change the narrative, shift the goalposts, whatever it is you're going to do, but at least acknowledge the video. Hey, it's okay. You know what? It's tricky. You're not the only one that doesn't know how the sphere works. I didn't know till I started digging, thinking about it really, because it's not information you can pick up. The way I present it, that the ground moves out from underneath the moving water, nobody's going to say it like that because it may, it's going to diminish their spinning ball Earth, and everything is about the propaganda of the spinning ball Earth. But I'm showing you as per Newton's law. I use Newton because I love it. Newton debunks his own theory of the spinning ball Earth. His first law of motion: an object at rest will stay at rest, an object in motion will tend to stay in motion at a constant speed and in a straight line. Oh, and by the way, I noticed in your video you put up Newton's first law, and you just accused me of leaving out the last part of it where it says, unless there's a net force that acts upon it or something to change it. You said I left that out, and ironically, and kind of funny, you left out the straight line part. Here's your quote. So from the video you did on me, I'll put a link in the description to that. So and ball earthers, ball earth advocates who are defending the ball are still saying he's correct. I don't know what part he's correct about or what they're saying, but they say he's correct. He's saying as a latitude line and a great circle, a small circle and a great circle, he sees no difference. They're just circles. And of course, I point out that they are a slice of a sphere. So for the longest time, goes back to Wolfgang Lahn, JSS Tiger, this is many years ago. Now, currently, Michael Dunleavy and CriticalThink are defending their sphere by describing a cylinder. CriticalThink put it as a bunch of stacked cylinders, small, thin, whatever, of increasing size till you get to the equator, and then they're smaller again. And this stacking up of cylinders is making up a sphere. And since I now just showed that by demonstrating that clearly the latitude lines are a turn, they're having an issue. So they basically want it to be a cylinder because then the ground moves like the equator. It moves in a straight line, like a great circle. Well, there are no great circles on a sphere except for the equator as far as latitude lines go. But they're trying to create some new model because I showed how the ground turns to the left. And as per Newton's first law of motion, the water, air, everything not tied down wants to go in a straight line. That's observable. That goes along with Newton's gravity being at the center of mass. That's how they have the concept of geostationary satellites. They have to be over the equator. There are no geostationary satellites. They know enough, of course, none of it's real because we're not a spinning ball. They may have satellites or stuff up there, satelloons or whatever, but not in space going around a spinning ball because we're not a ball. So there are no geostationary satellites above a latitude because geostationary satellites, like all satellites, orbit in a straight line. That's, of course, if they were real. Again, we don't live in a spinning ball, so there's nothing orbiting us because we're not a spinning ball. But in the concept of it, they have to go straight. And it goes along, it's consistent with Newton having gravity at the center of mass, which would be at the center of the Earth. Everything essentially orbits that. That's how he came up with his first law of motion. That when you throw something across the room, it goes in a straight line as far as left and right goes, right? But it's the beginnings of a great circle. So a geostationary satellite requires the ground to be moving in a straight line. So that's why you can have them, theoretically, over the equator. They have them like 22,300 miles up, supposedly, doing about 7,000 miles per hour, and they are in sync with the rotation of the Earth, so they appear to be overhead stationary all the time. Well, that's impossible at a latitude, and this disproves, again, CriticalThink, thinking that latitude lines are a straight line. You traverse them straight. Wolfgang Lahn, JSS Tiger, Michael Dunleavy all said the same thing, and other trolls, which I can't remember. But this proves the latitude lines. Well, there's twofold problem with the latitude lines. The latitudes are a turn, so a satellite, geostationary satellite, could not, it's impossible to stay over any position on a latitude. And number two, the center of mass, being what satellites are going to orbit around, will take it on a course to the equator, because that's what a straight line looks like at a latitude. Pick any latitude, put a straight line on it, it's a great circle, and it moves to the equator. It separates from the ground. It's not geostationary with the ground, if you will. So water, air, particles, clouds, anything loose on the Earth is essentially can act like a geostationary satellite, and it cannot stay in sync with the ground at the given latitudes. Period. Now, within the confines of the water, sure, but it'll bang up against the southern coast of lakes and any kind of large bodies of water, even ponds, anything above the height of surface tension. The water's going to move freely. Essentially, when you see pictures like this, beautifully 100% mirrored, calm, still, glass-like water, when the wind's not blowing, means that everything above the ground is staying in perfect sync with the ground. Okay? And in our case, the flat Earth, the reality is that's the reason we see this is because we're not moving. It's not possible in their model because everywhere the ground is turning out from under the water. If it wasn't, they'd have geostationary satellites over latitude lines. You know, and especially in light of the fact that they are now calling the Earth a spherelander. As I showed you, all them guys, Wolfgang Lahn, JSS Tiger, Michael Dunleavy, now CriticalThink, you know, they use a cylinder or cylinsphere or spherelander, saying that each latitude is like a little cylinder. Again, they would have geostationary satellites over all latitudes, but they don't, because they can't, because it goes against the ball, the sphere. They've got a problem. They're having to use the cylinder concept because I guess they know this because of the satellites. So they use a cylinder because that essentially everything could theoretically, if gravity's located at the pole, right, the center of rotation, not the center of mass, but throughout the pole that runs from north to south through the ball, if it was evenly distributed, then you could theoretically make the case that, yes, everything would stay put because everything's moving in a straight line like a great circle. But the great circles debunk them. There's only one great circle as far as a latitude line. That's the equator. A cylinder is a cylinder. A sphere is a sphere. All right. If anybody knows where Cricky is, ask him why he's not responding. And what does he think? Okay. We'll talk to you later.